When working with signal conditioning circuits, it might be useful to have filters in the circuit to remove unwanted noise. Filters, they are used to remove a certain band of frequencies from the signal and permitting others to be transmitted. There are a few parameters to be known, like the passband is the range of the frequency being transmitted, the stopband is the range of frequencies not being transmitted, and the cutoff frequency is the boundary between stopping and passing the frequencies. Also, the cutoff frequency is denoted by FC and is the output voltage, where it is 70.7% of the voltage in the passband. Another parameter is the attenuation, and it is the ratio of the input and output power, and is written as the ratio of the logarithm of the ratio and is thus given in the unit bells. But bell is a rather large unit, so we use decibels. We have two equations to calculate for attenuation. We have one where we take the input and output power and say 10 times the logarithm of the input, of the ratio of the input power and output power. And then we have another equation where we have the, can say 20 times the logarithm of the ratio of input voltage divided by the output voltage. If we say, look at the cutoff frequency, where we have the output voltage of 70.7% of that in the passband, then we should have an attenuation of 3 decibel. If you try to calculate this, you could say that if you have a signal in the passband that is 10 volt, and then it drops to 70.7% of that, then it should give you that at the cutoff frequency you have 3 decibel attenuation on the signal. For use with filters, there are 4 types of filter circuits that we talk about. We talk about low-pass filters, which allow all frequencies below the cutoff frequency to be passed on to the next stage, but all frequencies above the cutoff frequency are cut off. We have the high-pass filter, where all frequencies below the cutoff frequency are cut off, but all the frequencies above the cutoff frequency can continue. Also, we have bandpass filter, where all frequencies below and above the passband or the cutoff frequency are cut off, and the frequency in the middle is allowed to continue. And then we also have the band stop filter, where all frequencies below and above the cutoff frequencies are allowed to continue. And these you can see on the graphs here. The graphs show you with respect to the voltage and the frequency. Now, if we continue this, we also have 2 categories of filters that all contain these 4 types of filters that I talked about. We have passive filters that only contain resistors, capacitors, and inductors. The disadvantage of those is that the current drawn by the item that follows can change the frequency characteristic of the filter. And here it would be good to try and find out why. Active filters are like the passive filters, but have an added op-amp in their circuit. As an example of use of a low-pass filter in a signal conditioning circuit, where most of the useful information is in the low frequency and the noise is in the higher frequencies, then the low pass filter would block the noise in the higher frequencies. You might select a filter with the cutoff frequency of 40 Hz to remove interference from the AC main supply and the noise in general. Here below you can see two circuit diagrams. The one on the left has a passive low pass filter with only resistor and capacitor, and on the right you have a active filter which also contains a op-amp. As an exercise, you should find example of the other types of filters and equations to calculate what the cutoff frequency should be. Thank you very much.